Thank you.
Okay, thanks to you. Well, thank you everybody for being here. Thank you, Giovanni, and the people from the UK Smalltalk user group. Give me a second. Wait, there we go. I'm moving the, window to another monitor to see you. So, okay. I'm going to talk about live typing. You should be seeing my slide. Is that correct? Yeah? Cool. Great. So first of all, who am I? I'm a passionate programmer that happened to found 10 Pines. It's a software development company in Argentina, and also founded the Argentinian Smalltalk Foundation. And I'm also a professor at University of Buenos Aires. I've been teaching Smalltalk for more than 20 years. So I'm pretty happy about that. So type information in dynamically typed languages has always been a topic of research due to many reasons, mainly because, we want to be sure that we won't get any type error during the execution of the program, but also lately because we want to get advantage of the tools when we have type information, like for example, when doing a refactoring or auto-completion, all those kind of things. So there are mainly two ways to have type information in dynamically typed languages. One of them is type inference, and another one is manual type annotation. That is generally combined with type inference. And these are not new ideas. These are very old, almost like when I was born, well, a little bit later, but anyway, we can see here a little bit like 10 years more. But anyway, we can see here some papers from the 80s and 81 about type inference. The second one, the 81, is for Smalltalk, inferring types in Smalltalk from Suzuki. And you read those papers and, they're talking about the same problems, the same issues that we have right now when we want to add type information in dynamically typed languages. There has been also a thesis about that done here in Buenos Aires, in the University of Buenos Aires, but by Francisco Garau, that added type inference in Squeak in 90 something, 95 or 96, I don't remember the year. So it's always been an issue, something people have done. I have to mention also the role typer. That's another tool that does inference on types in Smalltalk. But, type inference has some disadvantages. For sure, we all know about them. Sometimes it gets a little bit slow. The information is not always complete, and sometimes it gives you invalid information. So you have to tweak a lot the tool, and it's not always, it doesn't work very well all the time. What about manual type annotation? Well, that's also an old idea. Dan Ingalls wrote a paper with Alan Bornin about that in 1982. As you can see, the idea is to annotate the types of the objects. Like, for example, in this case, that a block is a block that returns a Boolean, and so on. Also, we have Strongtalk. We talked about that a few minutes ago. Gilad Bracha implementation of type annotation in 1994. But none of these things are, very common in the current Smalltalk implementations, at least the ones that we use the most. They're like tools that we have in the back, but not really integrated, or we don't use them as much. The other dynamically typed languages like Python, JavaScript, and so on are adding more and more this idea of annotating types in the source code. Like, for example, TypeScript. TypeScript is now very used. It's very, people is starting to use TypeScript instead of JavaScript because of the type annotations. And as you can see, the idea is to add type information in the source code. We can see that in Python with type hints, and in Ruby with Sorbet, and it's starting to move, more and more on each of these dynamically typed languages. Just to give you an example, just to compare a little bit, with Python, how this works. I have here a very simple example. We have a class A that defines foo, class B that defines foo, and in C we send the message foo to X, and of course we have no idea the type of X. So if we try to rename foo from here, you will see that it is not possible because PyCharm decided that you don't have type information to do the rename, you cannot rename it. So, but what I can do is I can go here, let's say, and rename it from here. And like in Smalltalk, it will tell you, okay, I'm going to rename this implementer, but what about the senders? And it gives you, well, I don't know why here, but let's remove this one. It gives you, okay, you can remove this sender and so on. You can select to remove it or not, to rename it or not. But if you have type information, like in this case, and you say, okay, X is of type A, so now you can rename it from here and everything would work fine. So these are the kind of things that are pretty nice when you have type information, not only type checking, but having help in the refactorings and those kind of things is really useful. The same thing for add parameter, inline, and those kinds of refactorings. So what I'm trying to say here is that type information is starting to be important in other dynamically typed languages, and IDEs are starting to support that. But what are the disadvantages of type hints or adding type annotations in the source code? Well, mainly you have to change the syntax of the language, and this is something that for people like us that don't like to see type information in the source code, is makes it's harder to read that way. But mainly, the thing is that the programmer must annotate the types and the programmer must maintain the annotations. That's the most important issue for me, at least from my point of view. And mainly, all these type annotations are done for type checking. That's the main goal. So what's LiveTyping? LiveTyping is a new way to have type information in a dynamically typed language that is based on collecting the type while the system is running. So you could say, well, it's wow, cool idea. No, it's a cool idea, but it's not new. It's pretty old also. In the paper I showed you before about type inference in Smalltalk, written by Norihisha Suzuki, it's at the end, in the conclusions, he says that Al Perley suggested him that they could run the system against some examples and record all the types of arguments and results. So this is basically what we do with LiveTyping, but Al Perley suggested that a long time ago. And even worse, as we can see here, this idea has also been found in the thesis by Mitchell, but sadly I could not get that thesis, so I'm not sure what he talks about. But what I'm trying to show is that it's not a new idea. So LiveTyping is automatic type collection that is done by the VM, and a lot of improvement in the tools, in the Smalltalk tools, that allows you to use that information to have a better programming experience. So it's not a new idea, but it's a working one, and I'm pretty happy with it, and it's really useful. One important thing about LiveTyping, at least the way I decided to see it, is that the main goal is not type checking. It's not like the other type annotation tools for the other dynamically typed languages where type checking is the most important thing. For me, the most important thing is to improve the tools that we have in Smalltalk to give us a better programming experience, as I said. But as we will see, we have type checking also with LiveTyping. I'm going to show you some examples. those examples, I'm always using the same example. So if you saw this talk before, you know a little bit about what I'm going to show. The code I'm going to use is the tic-tac-toe implementation. A tic-tac-toe instances are, well, tic-tac-toe is implemented using a tic-tac-toe state, the design pattern, the state is design pattern. And as we can see here, the tic-tac-toe state have many possibilities, like, you know, is playing X or playing O, or the game is tied, and so on. And of course, we have all the tests here, many tests. It's not that simple, a tic-tac-toe. It looks like it is simple, but it's not like that. So that's the example I'm going to use, mainly to show the features I'm going to show. So the first one I'd like to show is how you can see the types while you are using or writing the code. The way it is working right now, when you want to see the type of an instance variable, a local variable, a return, or whatever, you just put the mouse over the variable and it will tell you the type. In this case, the type is, I don't know, a question mark, because I haven't run the code, I haven't run the test. So if I run the test, now I will see the different types of each instance variable. In this case, for example, the state instance variable had the types of playing X, playing O, player X1, player O1, and game tied. And all of them has tic-tac-toe state as superclass. The same as I can press Command Shift P and I will get the same information, but you know, in kind of a menu, and you can change, remove, or add types to this collection of types, and also you can go and browse a specific class that is there. So, but as you can see here, for example, player O positions, it says that it's an order collection, but we have no idea an order collection of what. I will show a little bit later on how we are changing this to be able to see the types of the objects of collections. And this information, we can see it also on any method. For example, if I want to see the type of a position, it's point. And if I want to see the return type of the method, it's a tic-tac-toe because it's it returns self. If I want to see the type of mark with X, mark with O at that is implemented in the state, is plain O. And what else? For example, here we can see that the return type of has player O1 has been false, true, and you know the superclass is Boolean. This is something really interesting because with LiveTyping you can see, in this case, if you cover all the possibilities, because the return type in this case was true and in another case false, so you get both types of Boolean. But if your test only covered the case of true, you will see true as return type. So it's nice to see, you know, have this kind of information. It's like a profiler in some way. Well, that's the way you can see the types, and it's very useful when you have things like I don't know. Let's go to morph, add alarm, and for example, you have delay time. What's the type of delay time? Well, you can put the mouse over there. In this case, it's never been used. Okay, here, delay time, I think here, yeah. So it's not a time, it's a small integer. So, you know, it allows you to see this kind of thing. So for example, R1, what is R1? So it could be all these things. It's a movable morph at the end, something that is in that hierarchy. Well, and a selector, it should be a symbol, okay? And you can see those things. So it's pretty useful when you don't know exactly what's the type of an object that, for example, a method is expecting as parameter. We used to have the option to see the types in the source code, but after, some people use it and didn't like it, and they like it the hover help information much better. But it's pretty easy to add an option to see the types in the source code if we want. Well, what about autocompletion? Autocompletion is very useful, and more every time. So let's see what happens when you don't have type information with autocompletion. For example, in this case, var1 has no type information because I never run any test on this class. So if I come here and I ask for the autocompletion, it will show me all the possible messages that I can send to that object, but without a clue. So it will show you everything. And in this case, it will show you the most used one. And as you can see, there is a difference in the color. Some of them are blue, some of them are black. And the difference is that when the message is in blue, there is no way to assure you that that message is going to be answered by that object. But when it is in black, it is for sure that it's going to answer that message because, as you can see, all these messages are implemented in object or in proto object. Okay, so that's why are in black. The objects the messages that are not implemented in those classes in this case are in blue. So what happens if I run the test and now I have type information? In this case, var1 is of type string. So now if I press the autocompletion, I will see only the messages that are answered by strings. And of course, if I start typing, I will see, the correct selectors. An interesting thing about this that I showed a little bit ago is that you can see also the implementation of the message with type information. And that helps a little bit to understand how the method works, the message works. So what happens when you have an instance, a variable with different types? Like in this case, var1 was assigned with a small integer and with a date. I don't know why you would do something like that, but at least for the example, it's cool to see it. So as you can see, the type of that variable is any, could be anything. So what I show here when you ask for the autocompletion are the common selectors, excluding object in this case. And as you can see, small integer and date answer the message plus, minus, less than, and so on. And if we go a little bit further, for example, here we will see that times, divide, and those other messages are not answered by objects instances of those different classes, but of one, in this case, small integer. That's why those selectors are in blue.
Hernan?
Yes.
Is there a reason why you have any rather than magnitude, which would be the common superclass?
Magnitude. In this case, let me see. I guess it's because it is not. Let me see, date. Date has not magnitude in this case. That's superclass. Yeah.
So why don't you show object then? I would have thought you would have shown the common superclass.
I was, yeah. At the beginning, I showed object, but then I changed it by any. Yeah. The reason is, what's the reason? Well, I don't remember exactly why I changed it by any, but it's because you are not sure exactly what. I mean, you know that all classes are subclasses of objects, so it doesn't add you too much value to see object. So I think that was the reason that I changed it. I don't remember exactly now why.
So if there was a closer common superclass, you would show it?
Yes, yes, yes. Let me show you an example. Uh, let me see here if I have that. Okay, let's add new one. I don't know. Let's say that we have something like this, and I don't know, something like this. So if we see here the types, we can see that are small integer, fraction, float, and they have number as super type. It's the same as here with the state. Okay, state has been assigned with instances of all these different classes, but the super type is tic-tac-toe state.
Thanks.
No, you're welcome. So yeah, that's how the auto completion works. And again, you know, when you get used to have that information, that if you have tests and you run your test very often, or if you don't have tests but you run the test and production, download the type information and upload it to your image, you can have all this information. And you know, it's pretty nice to see auto completion working as good as possible. And for new guys, you know, new programmers that are used to work with the statically typed languages, it's very interesting to see their reaction. It happens to me all the time with guys at the university that are used to work with Java or C++, and you know, they come and see that they can get almost the same type of auto completion in a dynamically typed language, and they get surprised. So it's very interesting. Okay, that's about auto completion. There is an interesting topic that I call dynamic types, that are, you know, in those, there are cases where you don't know exactly the type, but you have to deduce the type based on the context. Like, for example, the message yourself. What's the type of yourself? At the beginning, I said, okay, the type of yourself is object. But if you say that the type of yourself is object, then you lose all the information for example, for the auto completion, because here you know as programmer that the type is examples, because you are sending yourself to self. But if I say that the return type of yourself is object, then I will lose all the messages implemented in examples, and I won't be able to show them in the auto completion. So we change that, and we have this idea of dynamic type and self type that allows you to say that yourself, if in this case, it will return you, in this case, an instance of examples. If I have, for example, here, I don't know, let's do this. Temp2 now is in a small integer. So if I send it the message yourself, it will tell you that the return type is small integer. Okay, so it depends on the context, on who is the receiver of the message yourself. So if we look at the implementation of yourself, and if we look at the return type of yourself, we will see that the return type is self, with a lowercase self. That means that it's a dynamic type self. And that's something that is annotated in the code. It is not something that the VM, it's not that the VM collects the type. I can show you how that is annotated, if I'm not wrong here. For example, if you have a compile method that is a quick return self, so it will return a type information, the self type. Okay, so you can annotate types with live typing. It's not very common to do it, but you can do it. For example, if the method is a special return, for example, if it will return true in the case of true or false or nil, or if it is I don't remember exactly the how this work. Let me see. Sorry about that. My memory. Yeah. Well, I don't remember exactly how. Okay, here it is. It depends on the primitive. I forgot that. So if the primitive is 257, it will return true as return type. If it's 256, 258, it will return false, and so on. So those are the kind of things that sometimes you have to annotate to have a better type information. But the interesting thing is that dynamic types allows you to see the types based on the receiver. As I said here, yourself returns the type of the receiver. Class returns the class of the receiver, because class is also, depends on the receiver, the message. And here, for example, date today class returns date class as return type. So what's the good thing about this? The good thing is that now if I want to send a message to the return object, when I send the message class to mirror, I will see all the instance creation messages of that class as at the beginning of the auto-completion. And that's very useful too, because mainly you want to send instance creation messages to classes. That's the most common use. And the same thing happens with new. New is another message that the return type of that method depends on the receiver. So for example, here, it will tell you that the return type of new is a simple measure in this case, and in this case, it's going to say that the return type is a base unit. And the same thing happens with super. If you ask for the type of super in this case, it will tell you that is the superclass of example, that is test case. And if I go here and I ask for the type of super, it will tell me that the type is tic-tac-toe state, that is the superclass of game over state. So all these things are related to the context, and they allow you to have better auto-completion and when looking for senders and implementers and those kind of things. So that's a very powerful concept. Okay, what about implementers and actual implementers and those kind of things? Well, you all know that when we look for implementers, we will get many. For example, if I look for implementers of plus, we get 25 implementers. But in this case, I would like to see only the implementers of the types of temp1. And those are, small integer and date. So I can ask for for actual implementers. Actual implementers will show me all the implementation of that message in the hierarchy of date and in the hierarchy of small integer. So as you can see here, the first 7 implementers are part of the small integer hierarchy. It will go and look the implementation up to the, the superclass, the first superclass that implemented that message, and then it will go down and show all the implementers of that message in that hierarchy. And in this case, the last one, the 8th implementer here, is the one for date that is implemented in its superclass that is timespan. But also, we have the option to ask for actual local implementers. And in this case, it will show only the implementers for those types and not the whole hierarchy. So in this case, we will see only the implementer of plus for small integer and timespan. So what is good about, actual implementers is that it filters the space based, the search space based on the types of the objects that the message is being sent to. And that's really, really useful, and you will see why in a minute. So yeah, that's very important. For example, here, let's see this method. Mark with X add. This message marks with an X the tic-tac-toe at the position that you are asking it here. So the implementation asserts that the position is the right one, the correct one, and then it forwards the message to the state because it's in a state pattern. So if I look for implementers of mark with X add, normal implementers, it will show me 5 implementers. One of them is the tic-tac-toe, and the other ones are the ones in the state hierarchy. But if I look for actual implementers here, when the receiver is a state, I will only see the implementers of the state and not the one of tic-tac-toe. And if I look for implementers of mark with X add here, where the receiver is self, I will only see the implementer in this class, that is tic-tac-toe. So, it's like you can't forget about fake polymorphism in this case. Actual implementers allows you to filter the implementers to the right ones based on the types of the receiver. And this, of course, works, in any place that you put the mouse or the cursor. Okay, so I don't know if there is any question, or if I can continue. Okay. Then we have actual senders. It's the same idea, but for senders. And here there is something that I have to work on a little bit, that is the difference between sure senders and possible senders. And another thing that I have to work on was that the idea of sender is a little bit more interesting with LiveTyping, because now senders are not only the messages that, the method that send that message, but the place where that message is being sent. Because, for example, here you have two if you look for senders of mark with X add, the common senders, we'll get this method, and it will show you that you have these two senders. But in reality, if I look for the senders, I would like to see only the senders of mark with X add when sent to instances of all these types. So that's what actual senders do. So if I look for actual senders, in this case where the receiver is of type tic-tac-toe state, we will see only one. And we can see here in the source code that only this message send is the one related, is the real sender, and not this one. This one is not, a sender of that message to instances of tic-tac-toe state and its subclasses. Okay, so that allows you to filter a lot the search space for senders. What are possible senders? Well, sometimes you don't have type information. Let me see an example here. Let's see example. Okay, if I look for senders of example method, I will get, well, of course, senders, I will get these two places. But if I look for actual senders, I will get the sure senders. Those are the methods where I'm sure that the message example method is being sent to self. One of that is this method, and the other one is this one. As we can see, it's only selected this sender, this message send, and not this one. And then we have a possible sender, that is a sender in this case of that message, but to an object that we don't have type information for. So possible senders are senders that we are not sure if they are being sent to instances of the types that you are looking for in the senders. Okay, so that's what possible sender means. And it's very important because sometimes you don't have type information and you don't want to lose those possible senders. And also at this time, we don't support type information for local variables and parameters enclosures. So that's also important in that case. Somebody's working on that, but we are not done yet. So yeah, that's what possible sender is. And again, the interesting thing about actual implementers and actual senders is that they reduce the search space when you look for things. Okay, so how that impacts on the rest of the tools. So let me show you a little bit how a rename works in the typical basic quiz image without live typing. If I want to rename this message, well, it would ask me for the new name, and then it will ask me for the refactoring scope. You all know about this for sure. You have used the refactoring browser in the different implementation of a Smalltalk, and you always have to, in some way, select the implementers and the senders that the rename is going to affect. So in this case, it asks me if I want to do the refactoring in the class, in the hierarchy, in the category of the class, the hierarchy and its categories, or in the whole system. So if I select the whole system, it will look for all the implementers of that message, and it will look for all the senders of that message. And the refactoring will be applied on the methods that I select. But you have to do that by hand. With live typing, that's a little bit better. Let's say I want to rename this method marked with X at. I want to rename it, so I'll do a rename. I will rename it with marked with X at 1, just select the name. And now I have two other options to filter the space, the search space: actual and possible scope, or actual scope. If I select actual scope, the refactoring will look for actual implementers and actual senders. And that's where the refactoring is going to be applied. So in this case, because I selected actual scope and I decided to rename the message from here where the type is self, that means tic-tac-toe, so it will be applied on the actual implementers, that is only this method, and the actual senders, that are only these 7 messages. So let's do that. Let's do the rename. And it's very important to see here in the senders that is only going to rename this message send and not this one, because the receivers of marked with X at in this message send are not type of tic-tac-toe. So that's what I meant when I said that, the sender's idea, it's a little bit more, how can I say, deep or whatever, than the idea of senders that we have right now with Smalltalk. Yeah? Right now, with common Smalltalk, the idea of sender are methods. With LiveTyping, the idea of senders are real message send. So if I refactor, I rename this method, we will see that only this implementer is renamed, and only this message send is renamed and not this one. So that's really helpful. It allows you to avoid having to filter the implementers and senders yourself, and for sure making a mistake, because it's very common to make mistakes in those cases. What about the actual possible scope? Why is there? Well, because you can have things like this, and these are, some special border cases that you have to have in mind when adding type information to a dynamically typed language that is completely different, in this case, of a static type language. In fact, I can say that implementing a type system in a static type language without generics is much easier than in a dynamically typed language, because of these border cases like the one I'm going to show right now. In this case, we see that the type of temp1 are tic-tac-toe and examples, and of temp2 are tic-tac-toe state and examples. This is just an example. Don't worry about the why. It's just to show that example method is only implemented in examples. So if I want to rename example method, and temp1 has the type tic-tac-toe, you won't find that implementer in tic-tac-toe. So the actual, the rename or all the refactorings that use actual scope have to be aware of that. In this case, we will see that it will rename example methods in the examples class, but tic-tac-toe does not implement example method, so therefore it won't rename that. But what about the senders? Well, it will rename all the senders of that message. And in this case, I selected actual scope, so it won't rename this message send. But if I select, no, sorry, I'm going to use another, example method 1. If I rename using the actual possible scope, then it will rename this possible sender too. So let's do that, we will see that here, that message send was also renamed, even though we don't have type information for this variable. So those are the things that you have to have in mind where implementing refactorings with LiveTyping. Right now, there is a guy implementing the inline refactoring, inline method, and having type information works exactly as the rename, as the add parameter or remove parameter refactorings. It's very useful to have that kind of information when doing done refactoring. It allows you to do an inline in a very, very similar way as in an statically typed language. Okay, what about the types of collections? As I told you, right now, if I look at the type of this instance variable, it will tell me, okay, this is an order collection, but I have no idea what's the type of the objects in that order collection. So if I want to see, I don't know, player X position, if I want to see the return type of last, it will tell me, okay, it could be anything, because it had so many types. The return type of last in order collection has been used with so many different types that it could be anything. Okay. So what's happening is that we are losing the type information of the objects that are put in a collection. So there are two guys that wrote their thesis, master thesis, to add type information in collections. And we have right now this class that is typed order collection. And so let me reset the types. What's going on? Okay, I don't know. Could happen. Let me see. Well, they have to work something a little bit more to make it work. But anyway, let me do this. There you go. So if we look at the types right now of numbers, I didn't run the test, so I don't know. But if I run the test, as we can see, one is being added to that collection. So now if I see the types, we will see that it's a type order collection of a small integer. So we don't lose the types of the objects that we add in that collection. And the good thing about that is that now first, for example, is going to tell me that the type, the return type of first is a small integer. So if I look for the actual, for the, if I ask for the auto completion, it will show me the messages that you can send to small integer. So, it's like having generics, but that are collected dynamically while the system is running. The same thing happened here, for example, for last. If you want to see the type of last, in this case, it will be small integer. But what happens if I, instead of a small integer, I use a string? Well, let's use another string. Okay, so now the type information is type order collection of string. So the return type of first is not small integer anymore, it's a string. So the auto completion shows me the messages that string knows how to answer. So it's all integrated and it's really, really cool. What happens when you add different types of objects to a collection? So we get the, in this case, the type of the elements of that order collection are small integer and string. So it could be anything. And of course, the return type of first is small integer or string. And again, if you ask for the auto completion, you will see the common selectors excluding object and the messages, specific to, for example, a string or to, I don't know, to an integer, like, for example, divide and so on. And of course, this works also for collection of collections and all that. So for example, here, it's not really integer and fractions that we are adding, but we are adding typed collections of integers and type collections of fractions. So if I look at the type here, we will see that it's a type order collection of type order collections that could be in small integer or fractions, and the superclass is number. So now the type of first is a type order collection that has numbers inside. So if I ask first, now I should see that the type is number, a small integer or fraction, and therefore I can see here the messages that I can send to instances of small integer and fraction. And of course here, if I ask for the auto completion, it will show me only the messages that are answered by typed order collection. So, it's very useful. You got all this help, all the help you can get having this type information, and it helps a lot. And it helps a lot to newcomers, to new Smalltalkers. Again, it's like having, it's like working with a statically typed language, but better with a dynamically typed language. And finally, yeah, we have type checking too. You can type check a class, a method, or a category. For example, here, we don't have errors, but let's go here. And let's see, for example, IV1 if of type small integer. And look at this, it says that can be nil. What does that mean? It means that nil was assigned to that variable. So we can see that here in the setup, IV1 has been assigned with 1 and with nil. So it tells you that be careful, that variable has been assigned with nil. And that's very useful information. It's the same as knowing if the return type is true and false, or only true or only false, because you know exactly, if all the cases were tested. So here it tells you that it can be nil. And so if I type check this method, it will show me the errors. And in this case, date is not implemented in a small integer and in undefined object. So I can change that. I will send a message that every object knows how to answer. And I save that, and then the error disappears. And now it says factorial is not implemented in undefined object. So, okay, if the problem is undefined object, I can say IV1, if not nil, then IV1 factorial, because it's going to be a small integer. And in that case, there is no more type error. And you can see here that the type checker knows how to handle this kind of dynamic type checks, or casts to, to avoid sending messages to invalid objects, invalid messages to the objects. That works with if nil also. For example, in this case, IV3 can be nil. So if it is nil, nil implement the message subclasses. So if I type check this method, there is no error, because nil knows how to answer subclasses. Undefined object implement that message, and so on. The same thing happens with or. In this case, IV3 can be small integer or nil. So odd is only going to be sent to IV3 if it is not nil. So if I type check this, it's going to work. So the type system, the type checker, how to handle all these kind of things. And the same with is kind of, and those kind of common castings that we usually do. Or for example, this one, small integer, if IV5 class is of type small integer, then return, and if not, send the message first. So in this case, only when IV5 is instance of a string is going to answer the message first. So this is an ugly, way of testing the type of IV5. But you could do something like this, and if we type check it, it will work correctly, because it knows from that if IV5 is instance of small integer, it will stop the execution here because of the return in the closure. And all those kind of things that are very tricky that you have to take care in a type checking system, in a type checker, as in a language as Smalltalk. For example, this one is very interesting. IV7 is of type small integer, order collection, and color. And color, I don't know if in this version, I think it was removed. Yeah, it's collection. Okay, so look at this. Color returns false for is collection. And of course, it returns false also for small integer, but it returns true for order collection. So you can have, this is a very complex case analysis. So if IB1 is collection, so how does it know if it is a collection? So it looks for the implementers of its collection in the types of IB7, and it looks for the return type of those implementers. So if we go to local implementers, we will see the return type of is collection in the class collection returns true. In color, the return type is false. And in object, the return type is false. So in this case, it only returns true when IB7 is of order collection. So I can send the add message. And if it's not that, so the types are color and small integer. So then I check for number, and it will type check only if it is a number, because number knows how to answer plus. And if it is not a number, it means that it's a color, and color knows how to answer alpha. So if we type check this, it will return okay, because all the filtering of types is done correctly. If I remove, for example, this, and I leave this like that, and I type check, I will have a type check error because alpha is not implemented in a small integer. So, the type checker takes care of not all, but almost all of the type checking things that you usually do dynamically with Smalltalk. Okay, we could check. Let's see. Let's go to behavior. This is an example I like to show, and see for let's type check behavior. Behavior has like how many years? 40 years, or maybe more. If we type check behavior, we get some errors. Most of them, let's see here. Most of them are because subclasses do is not implemented in behavior. And we are, of course that we will never have instances of behavior, but the problem is that behavior doesn't implement subclasses do. Subclasses do is implemented in class description, class, meta class, and so on, okay? So if we want to remove this error message, we have to implement subclasses do in behavior as subclass responsibility. And after that, we won't get that error message anymore. Well, it's not necessary to type check again, but we won't see that error message again, okay? Well, that's basically it. There are other errors that these are not real errors. For example, in this case, the type checker is not handling this case of the while false. I haven't had the time to filter in this case that in lookup class is never going to be nil inside this block because we have a while false here. So yeah, it's a very interesting tool, but to tell you the truth, I never type check my classes. I just run the test, and if the test run, I'm happy. So that's why I'm telling you that, as I said at the beginning, type checking is not for me the most important thing of live typing. I like more the possibility of renaming the right implementers and senders, and having a good auto completion and those kind of things. Those are the things that are more important for me. Okay. I have also yes.
For the type checking thing, if you wanted to make it part of like a CI build or something, like say you had got all the types right and you wanted to make sure that you didn't break it, is it something you show a list, but is it something that you can do to get a result back, so that you could sort of automate it in some way?
Yes. I don't remember exactly. Let me see. You have the type checker, and that type checks a method, or many methods, and
you can get a result back, I guess, and check that it's empty or something. Yeah. Okay. Yeah. Cool.
Yeah. And you can do, those are objects. So it's a collection of messages, and those are type error objects and those kind of things. So you have here type checking result, and you can see that if it is an error, if it is a problem, if it is a warning, and those kind of
okay, cool. Yeah, yeah. Nice.
It's very, very interesting. Yeah.
I didn't realize how far it went. There's been a few messages in the chat sort of also mentioning
thank you for
like, wow.
Thank you for the question. I usually don't show as much this because it's type checking, but anyway, it's very complex. I don't like. I have to rewrite it because there's the way it filters the types is not. I mean, it works well, but it doesn't support some cases like the while false, while true, and those kind of things. So I have a new idea on how to do the type checking, but I haven't had the time to rewrite it. And also something that I would like to do is to use the type checking for the auto completion. For example, where was it? No, not this one. I think this one. So here, I will, if I want to see the type of IB5, it shows me a string and small integer, but I would like to see only, maybe not here, but in the auto completion, but let's say I know here that IB5 is only of type string. It's not small integer because if it is a small integer, it will stop here, it will return. So, I have that if I use the type checker to show the types in this case, I should be able to show, IB5 in this case is only going to be an instance of string. And if I can do that, then, the auto completion is going to work in a better way, because right now, if I ask for the auto completion, it will show me, the messages of small integer and string. But this is not correct, because in this case, IB5 is only instance of string. So those are the kind of things that I would like to add, to put the type checker inside the other tools. But, the type checking is the last tool I wrote. That's why it's not integrated with the rest of the things.
But all seems doable. It's just a case of
of course. It's a matter of time. It's not difficult. Yeah. Oh, it's amazing. Doing this, it didn't take me more than, I don't know, 2-3 months. I mean, it's not something that it took me years to do it. It's a small talk at the end. It's simple. I don't know, Juan, you raised it. Yeah.
Yeah, it's just a matter of adding a new test case to a test suite or to tweak a bit SUnit to run a special test that type checks all the code base, right?
Yeah. You could, you could have a test that runs the type checker on all the classes that you want, and it will work correctly. Yeah.
Looks like a useful thing to do for.
Definitely. Yeah, definitely. Like Tim said, having that in the CI is very useful. Would be very useful. Yes.
Yeah. Really impressive. This code analysis thing I wasn't aware of at all, and it's really amazing.
Thank you.
Congratulations.
Yeah, I don't know why I didn't show it that much the other times, but anyway. I don't know if you want to see how this is implemented or not. I have a few slides about how it is implemented in the image and in the VM. If you want, I can show that. Yeah. Okay.
Yeah, just a small comment, I think, related to your any. So I think we saw one example where you showed, for example, for a collection and the return type for accessing an element of an untyped collection. Yes, that one is clearly should be any, because we really don't know what it is. It could be a proxy class or subclass of nil. But I think you should use both. So in case where it's either a string or small integer, they do have a common superclass, which is object. It's not any, because they are not subclasses of nil. So I think both should be used, but any should be reserved for cases where truly it could be anything, not just object.
Yeah. That's I agree. When I think about those things, I go back and forth all the time. But yeah, it's a matter of just changing, what you want to show. It's not really that there is a type any. I haven't verified the concept of any. It's just when I see that the super type is object or proto object, instead of putting the name of the superclass, I put the string any. So
yeah, but strictly speaking, both object implements many methods. So
yeah.
we do know things about object. You can have a subclass of nil that doesn't have any methods. So they are very different things.
Yeah.
So that's why any is different than object.
Yeah.
I mean, I speak from experience because I implemented type inferencing for Smalltalk. So we.
Oh, cool.
Yeah.
Great. Okay. Yeah, I think I changed it from object to any when I read a paper about how other languages use that idea. And if you annotate the types in Python or in Ruby, and you want to say that the return type of a method is of any type, you use any. So I think I took the idea from there. But again, it's not something that I completely sure that is a good idea. And as you said, it may not be a good idea. So how this works? Well, depending on what are you collecting types of. For example, if we want to collect the types of instance variables, those types are collected in a new instance variable that I added to class description. Class description has a new instance variable called instance variable row types. Instance variable row types is an array of arrays. As we can see here, let me show you. It's an array of 10 elements. Oh, in this case, not sorry. It's an array of the size of the instance variables defined in this class and its superclasses. So if examples, all instance variable names size is 12, okay? And in each of these positions of the array, we have another array. And this array is what I call the types array. And that's where the VM puts the types of that instance variable. In this case, the first instance variable is test selector. So in the first position of this array, you will have an array of the types that test selector was assigned to. Okay, so we see that test selector was only assigned with instances of symbol, as we can see here. The type array by default is an array of 10 elements, but is configurable. Could be 10, could be 100, could be 1, and it could be nil. If you don't want to collect the type of an instance variable, you can put here nil, and we won't get type information for that instance variable anymore. And here, for example, we have the type information for the other instance variables. So that's where the type information is being stored for instance variable. And how does that works at the VM level? Well, at the VM level, every time I change the how do you say, with the implementation of the bytecode, when you assign something to an instance variable, it sends the message, keep instance variable type information for this object on this receiver at that index. So it does some checking to get the class of the receiver, blah, blah, blah. And then it sends the message, keep type information in this type array at this index for that object. So then it looks for the right type array in the first array. And then this is the one that does all the work. It checks that the type array is not nil. If it is nil, it doesn't store the type information. And if it's not nil, it gets the class of the object that you are assigning to that instance variable. And then it looks for the first place in the type array where he can put that new type. So it goes from, well, in this case, because it's the VM, from 0 to, let's say, 10 to 9, and it checks if the, it takes the type of that index from the type array, and if it's equal, you know, if that type is equal to the type of the object that I'm assigning to that instance variable, that means that, you know, that type is already in the type array, so we don't have to do anything, we just return. If that type is nil, that the element in the type array at that index is nil, it means that we found a place to put the new type. So that's where it puts the new type and returns. And of course, if it's more than 10, you know, if the types array is full, the type is, we lose the type. So, you know, right now the limit, but that's configurable, as I said, but by default, we have 10 elements for the type array. And that's more than enough. You know, at the beginning, when I started with this, I didn't know which length to use. And, you know, I decided to use 10 because we have 10 fingers. And I say, okay, let's try with 10. And I never changed it. I never changed it. It works pretty well. It's not common to see instance variables or any kind of variable with more than 10 different types. Well, and the same things happens with methods. When you know, the types in methods are stored in the class additional method state. In additional method state, we have variables row type and return row types, and a little bit more things that I'm gonna skip this because it's for the variables that are accessed from a closure, you know, all the remote vector stuff and those kind of things. But it doesn't make sense to talk about that right now. But instance variable row types and return types is where the types of the parameters and return the parameters and the return types are stored. So let's see. If I inspect this method and I go to the additional method state, no, this one. We will see here variables row type is an array of 5 elements because this has 1, 2, 3, 4, 5 parameters. And it works the same way as for instance variable. So we have an array of arrays, and you know, this is the type array for the 3rd parameter, and this is the type array for the 4th parameter, and so on. And the same thing with the return type, but in this case, we only need the types array for the return. It's very simple, and I decided to use array because it's a very well-known object for the VM. It's very easy to use it. And you know, the changes I made to the VM are very, very simple. It's just a couple of methods that take care of looking for the right array and then putting the information in the right place. No more than that. It's very, very simple. This implementation I did is for the stack VM. Yes, I'm not very, and I don't usually work with VMs. I know a little bit about VMs. I read a little bit about VMs, but I'm not an expert of VMs. And you know, I was able to do that because of that great idea that Dan had when he started Squeak and wrote the VM of Squeak using Smalltalk. So that allowed me to make these changes, you know, and you know it works pretty well. But it would be great to have these changes working for the JIT VM. Sadly, I don't have the time. I haven't had the time to do it for the JIT VM. So that's about it, how it works. As you can see, it's very, very simple. It's not something complicated.
So every method will have one of its literal slots be that additional properties or nil. So, but all the compiled methods will have that slot, but if it's nil, it won't do the tracing on those methods.
Yeah, that's right. Okay. I mean, you can say, I don't want to, you know, trace I don't want to collect the types for this method for the variables and argument, you know, and local variables of the method. So you put nil here, and it won't collect types anymore for the parameters and variables of that method. Or so,
but in the actual compile and method itself has to have an additional method state.
Yes. Okay. In this case, every method has an additional method state. Yeah, that's right.
Okay, because of the hassle of dealing with the with instance variables and compiled method.
Yeah, that's right. I mean, but you could remove the additional method state. I mean, I think here it used to have the name of the selector, selector, yeah. So I can put here the selector, and you know it. What happened? It should. Why is not changing that? Oh, I cannot. Maybe I have to send a message. Yeah, for sure. Anyway, instead of having the additional method state, you can have the selector there. That is, basically how it used to be before. And the VM, it won't collect types for the parameters and the return types. So you can have methods without the additional method state, and everything will work fine.
So
that's being taken care. Sorry, that's being taken care. Where? Not here. Oh, I didn't put that in the code, but it looks when it changes.
The second line, I see it.
Okay, it's somewhere.
So if the additional state is nil, then you just don't do anything. The second line.
Exactly. Not nil, but it's a selector. It used to be a selector. Oh. That's where the name of the method used to be in the the previous how do you say this? Penultimo. How do you say that in English? Penultimo. The previous of the last. That's right. That used to be a selector, and that's the name of the selector of the method. That's basically when you don't have additional methods, then you have that.
So this is all based off of quiz, right?
I ported it to Squeak a long time ago, and it worked with Squeak. But
is there a process of taking the Squeak image with its ordinary compiled methods and then modifying all those compiled methods so that it's ready for your modified VM?
I mean, you can do that. There's no problem. It's just a matter of installing the LiveTyping package in Squeak, And when you install that, it takes care of everything. It makes
Okay,
all the
okay.
changes that you have. And then after you do that with the normal VM, you can start using the LiveTyping VM. By the way,
Okay.
and you can use the image with LiveTyping information with a normal VM too. So the image, it's you can use the image with either VM. But if you use an image with type information with the VM that doesn't collect type information, you won't get the collected types, but it works.
One comment, please.
Yes.
Live typing is not included by default in Quiz. So if you want to install live typing in any other dialect, all you need to understand is how it is loaded, how the loading process works in Quiz. Okay,
Mhm.
it's done each time you load it.
That's right. That's right. The same thing I did for Faro at the beginning. Adding, live typing, installing live typing in Faro was a little bit complicated, but it didn't work at the beginning because adding an instance variable to class description never ended. So I had to change the bootstrapping of the Faro image to add the instance variable to class description in the bootstrapping. It worked, and I changed the I ran a Faro image using the squeak with the live typing VM, and it worked. But that was just a try to see how if it was possible or not. And then we wanted to add this type information to the Faro VM and use it with Faro, but the pandemic stopped us, and we didn't have the time to do it. But it's pretty easy to port to any other squeak kind of Smalltalk. Okay, so some statistics, performance. So what's the impact on performance? Is very, very low. It's just 1.4x. And when you are working, when you are programming, that's you don't see that. You don't see the difference. You see it when you run the test. They take a little bit more, but it's if your tests run fast, then there is no problem. So it's not really an issue. And about memory, it's about also 1.4, 1.5. It depends, but that's configurable. Like I said, the arrays, the type array is right now by default has 10 elements, but you can decide to shrink. There is a message that you tell it to like type in shrink all type arrays, and removes all the nils and makes the types array smaller. So, but by default, it's almost 1.4 memory. So, as conclusion, is we know X4, we can have type information and get rid of the most of the disadvantages that we usually have when working with dynamically typed languages. The fake polymorphism, too many senders, too many implementers, and those kind of things. And something I like about this is that you don't have to do anything. It just comes for free. If you have tests, it comes for free. If you try your code and you use your system, that's something that we should do before shipping a product. You have all this type information for free. And if you don't do that, you can collect the types on production and import those types in your development image. And, again, it's for free. That's the cool thing. Of course, it has some disadvantages. If you pass as a parameter an object that is not of the right type, you will get, the type for that parameter will have this invalid type. So there we have to work some things to make it more reliable in those cases. But it's very simple. I have some ideas. For example, one could say that you want to freeze the types of a parameter, or to freeze the types of the return type of a message, and those kind of things, and then you have no problems. Also, right now you know, if you add a proxy, you know, if, for example, if you send a proxy of an object as a parameter, it will add the proxy to the type information. But if that proxy implement the message is proxy, the tools take care of that. Okay, so it works for those cases too. So the good thing about LiveTyping is that it makes type explicit. You don't have to remember or infer the types anymore. You have the information there. They are objects, and you can play with them like any object. And you know, it's a very simple technique. It's not something complicated, and you know, the impact is big. When you start using it, you don't want to lose it. It heavily improves your programming experience. It doesn't change the syntax. It doesn't stop you from compiling. It doesn't force you to use it. If you don't want to use it, don't use it. And it doesn't clutter your code, your source code, with information that you may don't want to see. So yeah, this is something I like to say. I humbly believe it respects and honors the Smalltalk spirit. Well, I don't know if you agree with me, but I think so. And of course, this is something I thought when I gave this presentation at ISU 2 years ago. I remember Jane Foster asked me why I'm doing this, and I started thinking why I'm doing this. And I think basically it is because of this. I would like to see Smalltalk to you know, to be said that it's a lively type environment and not a dynamically typed environment anymore. And I think that it will help Smalltalk a lot having these kind of tools and type information. Okay, there is a lot of work to be done. Like I said, currently we don't support type information in the closures. It should be done. This, you know, Ines is working on this, but she doesn't have too much time because she's doing this for her thesis, but she's also working. So sadly, she doesn't have too much time to work on that. We added support for parameterized types only for order collection, like I showed you. Now I have to work with other guys to make it available for other types of collections and classes like association and so on. There was a guy working on the JIT VM, but sadly he moved to Germany and he stopped working on his thesis. So if somebody wants to implement that in the JIT VM, let me know. And there are more and more refactorings that we are adding to the quiz image using the LiveTyping information. Fernando, for example, is working on the inline method that it heavily uses the type information. And there are many, many ideas that we can add, you know, that we can add to LiveTyping, like, for example, more typecast in the type checker, to use the type checker in more places, not only to check types, check the type of parameters and freeze the type of parameters with some annotated types. Like I said to Tim, you know, use the type checker to improve the auto-completion. You know, many things, improve the type checker to warn about dead code. And also, and this is something, you know, the VM people doesn't like this idea. I'm not sure exactly why. Well, I have an idea, but, you know, once you have this type information, why not using from the VM to generate the peaks and so on? Because in some way, you know, peaks and these things that that I'm doing with LiveTyping is collecting type information. It's almost the same idea. The difference is where you are collecting it and when you are collecting it. So I think, you know, code generation could use that type information to have better to produce better code. Oh, well, the delete method with transitive closure, that's done. I've done that. You know, you don't have to, when you want to remove a method that has senders, but that doesn't have senders and that doesn't have senders, you have to do it by hand. So right now it does it by itself because it checks the types and look for the actual senders and so on. So it does the closure, the transitive closure, and it removes the method correctly. You can download it from here. It's Quiz with LiveTyping is and other packages is something that we call Quiz University. That's the image that we use for teaching at the university. So if you go to that address, you can download it. You can download Quiz University with all the things. It's just downloaded. It's a preloaded image with the right VM, and it works. And you can get the VM code, and there you have the repo for the LiveTyping package. Okay, I think I cover all the things. I don't know if you have questions, comments.
Have you considered other more complicated rules? So not just self types and things like that, like the method returns the type of the argument for, for example, for output or things like that, or returns the type of the block argument return and things like that. So
Yeah.
more and more.
Yeah, of course. The thing is that it's not type inference. That's very important when you're doing type inference. In this case, you don't need to annotate or to write those kind of rules if you're not if the return type or the type of that instance variable that you want to return is not a generic. You see, if it is not a generic, so it doesn't care. You will have the types of the instance variables. You have the types of that method, the return type of that method, and they will be the same because that method is returning that instance variable. So there is no need to do those kind of inference unless you want to have generic, and in that case, it's a little bit more complicated. Yeah, I agree. But one of the ideas I have is to use type inference for generics. Because in type inference you have to start from some information and then get more and more and more type information, and starting is very difficult. Because when do you stop looking for the types? With LiveTyping, you have the beginning of type inference. All that information is there. So maybe in some cases, like generics and those kind of things, type inference will work pretty well and fast because you have that information already there to start. But those are ideas that we have to work a little bit more on.
I think everyone is stunned. It's really cool. Wow.
Well, when nobody asks too many, when there are not too many questions, it's because the presentation was good or really bad. But anyway.
No, it was a great presentation. The only way it could have been better is if the orange book was on the same shelf so you don't block it.
Sorry. There you go.
I'm especially interested in getting production information into development images. That sounds really cool.
Yeah. It's pretty easy. I mean, it's just it's an array of classes, so you just download that and upload it, and it's pretty easy.
Yeah.
But
it's built into the framework. Is that something that you is that built in? Is like you send some message, get a file, and then you can.
Yeah. I did it. I never use it, but just I did it for testing and those kind of things. I never use it because I don't have any system running with LiveTyping, sadly. But yeah, it's in the framework. Yeah, and it's something the guys from Apple did that. I'm sorry, Apple or Facebook, I don't remember. I think, I think Facebook, I think they did that for the PHP VM. Yeah, the guys at Facebook. They have also a PHP VM that collects types, but because PHP is not a mere circular system, they cannot get the types correctly when working. So they run, they have some instances of the PHP VM that collects types, and then they use that type in development to help them with the tools and those kind of things. There is a paper about it. I think I referenced that paper in the paper I presented at the Programming 19 in Italy. Yeah, I referenced that paper there. I don't remember the name right now.
One thing that could perhaps be useful is to deploy your application, including live typing, and at the customer side, if a new type that wasn't already in the set of collected types appears, then raise a kind of alarm. Okay, because it would mean that your tests were not good enough or something unexpected happened. And maybe that could be a very early warning on some possible problem with the system, right?
Yeah, that's a good idea. Yeah.
So it strikes
That
me,
is cool.
if you imagine this being used on production systems, you have to take into account that the fact that software evolves over time. And the data gathered from a system at one version of a system might actually provide misleading information if you applied that then to something like the next week or the next month.
Yeah, that's something that you have to be careful with. Yeah, you could get misleading information. That's correct. But at least it's information.
It is. No, it's great. I mean, one could imagine embellishing the information you collect to record, I don't know, the hash identity of the classes involved. So you would know what version of what class was used. But overall, it's brilliant. Thank you very much indeed.
Oh, thank you. So yeah, what I can say is that right now, for example, when we ship Quiz University, we ship it with both VM, the LiveTyping VM and the JIT VM that doesn't collect types, and we tell the students you have these two options. The LiveTyping VM is a little bit slower because it's the stack VM, and you have the JIT VM, it's faster, blah blah blah. But the LiveTyping VM collects the types and helps you with the auto-completion and the senders and implementers. And, the other day I asked them, okay, which VM are you using? Everybody's using the LiveTyping VM. Because, when you are writing code, you don't care that much about performance. And all that information helps, the programmer a lot. And, that's cool to see.
I can imagine it working really well when you get into a code a bit test, because all the time the model is being enriched and you're getting better and better information as you develop your code.
That's right. So, yeah, that's right. Yeah.
Really nice.
Yeah, it's very helpful when you do TDD and those kind of things. Again, at the university, we teach TDD. The way we teach them how to program is using TDD. So everything's goes together. And of course, I would like to see this on commercial small talks, but it takes time and money to do it. And there are many things to improve on what I did. As I said, I spent only 3 months working on this. I'd like to have more time to make more things, but we'll see. We have time.
I'll chip in this as well. I like your take on typing, that it is something which can provide certain values, but it adds clutter to the code if it's explicitly added to the code. The changes that have been made to some languages, for example, Python, really do compromise the code in terms of its readability. And they also compromise it in terms of polymorphism as well. You can't use code in such a flexible way if you actually lock things in. And a lot of people, I think, use this as a crutch for their programming rather than being an aid to write better code. They're using it as some kind of a, I don't know, arse covering thing or something like that. I don't know quite what, but it's, yeah. So I'm with you anyway, I think.
Yeah, you know, that's why I said that for me, LiveTyping is it's not about type checking. It's a tool, a very nice tool to have, but I prefer the programmer to decide the types and you know how things work. And okay, just type check them if just to be sure that you're not making a big mistake. But sometimes you have to make compromises on the types of the objects, and you know that's correct. And you know, this LiveTyping doesn't stop you from doing those things.
So the live typing is conservative. As your image runs, you'll add more and more classes to it. There's no reset to say, okay, I now realize that these classes don't fit. So you'd have to clear them all. I presume there's some utility that will clear them all, and then you could rerun your tests.
That's right. I mean, currently it adds type information, and that information gets resetted when you change the shape of a class. When you change the shape of a class, adding an instance variable or removing an instance variable, it removes all the type information from the instance variables. And when you change the method, it removes all the type information from the parameters, local variables, and return type. That's the way it works right now, but that's configurable. I mean, you could change that. If, for example, you could keep the types from a version of a method to the next one, you could do that. It's not done, but it's possible to do it. Right now, it is like starting over. Every time you change a method, it removes all the types. And you can do it also by hand and say, I want to remove the types of this class, of I want to remove the type of all the classes in this category, and so on. Yeah. So the question, you know, everybody from statically typed languages have is, okay, but how are you sure that you are covering, you know, all the types? You know, they're afraid of not being perfect. And I say, okay, it's not perfect, but it's good enough, more than good enough. It's really, you know, I cannot formally prove that it helps you, but I can practically prove you that it helps. So, you know, these are the kind of things that you usually have to talk with people from statically typed systems. I like to have a better explanation, a more formal explanation of showing why it covers very well all the cases.
I could offer something.
Yeah.
The thing about the typing is your light typing empowers refactoring. Whereas when you've got actual static typing, that's like a tax on refactoring. It's basically, you can't just refactor your code. You've also, often the whole point of refactoring is you're rehandling which types, you're migrating behavior up the hierarchy and state down the hierarchy. And so your the types that your methods are accepting are changing. And static typing is like a tax. You've got additional, I mean, it's like you have additional forms to fill in or something before you're allowed to do this. So what you could say to them is they're paying a heavy price for their perfection. You can show that you're pretty good, and their perfection is making refactoring more expensive. Whereas this is really nice because it does actually make refactoring easier. It gives you all the dynamic refactoring flexibility and just enough safety to be only a gain. I offer that thought for what it's worth in your argument.
Yeah, thank you, Neil. Yeah, I completely agree. I like it. I'll take it.
There's actually a paper because the self one that was implemented by Craig Chambers used type inference.
Yeah.
And self 3 that was implemented by Urs Husel used the polymorphic inline cache, which is type feedback. So they actually have a paper, I forgot the title, I have to search for it, where they compare the two, because type inference is complete. You never miss any types, but type feedback is not complete. So they actually did a comparison. I don't remember if the comparison was in terms of performance or in terms of which cases you miss or something like that, because it's what, 30 years now or something like that since I've read the paper. But the comparison between self 1 and self 3 is exactly that. Do you need to cover every single case, or is good enough good enough?
That's right. That's right. Yeah, I remember you told me about that paper, but I haven't read it. But again, I can offer my experience. And like I said, when you have this information, even though it's not perfect, it's almost perfect. It's good enough.
But this is another incentive to get better unit testing, isn't it? Because the better your unit testing, the better information you're going to get out of this.
That's right. That's right.
That's the response to these static type people. You just go back to them and you say, so you've got rubbish unit testing, have you? Ha ha.
Yeah, that's a good point. Yeah.
I guess that one thing that happens with going back to type inference, with you said, Hernan, that with live typing, some people are afraid of some false negatives. I mean, types not being captured. But if you do full type inference, you will have a lot of false positives. You will know less. There will be a lot of places where you can tell very little on restricting the possible types. So the interesting statistic would be how much negative positives live typing might provide against how many false positives type inference would provide. That would perhaps be a fair comparison between the approaches.
Yeah, that's a good point. Yeah.
But can the two be complementary? That is, within the same system, you could have type inferencing running at the same time as you have live type.
Yeah. Like I said, I think live typing could help a lot to type inference. In those edge cases where it's difficult to infer the types or it takes time because you have some type information already that is correct.
You said earlier that your talk was like in the spirit of Smalltalk. And I really like that, because one of the things I love about Smalltalk is it's that nice exploratory playing around environment. And I mean, I'm still in my love-hate affair period with static type systems, best exemplified by Haskell. And I like the way you have these rigid shapes that all fit together according to your perfect design, which is great when you know what you're doing. The trouble is when I'm sitting down to, I sit down in my Smalltalk environment and it's like, I don't know what I want to do. And this looks good because it lets you do the complete dynamic programming thing, explore. And, as you make a few iterations, sort of start getting what you want, I can actually seeing the type information that is collected by your system being used. It's like, oh, now I got a better idea. Now I think I can actually express this in actual static types where you get that certainty. I always said like Smalltalk leverages confidence, static type systems leverage certainty. So yeah. I like it.
Sorry. Yeah, what you were saying? I missed the last part, Mike.
Oh, so one of the things I always said, especially like the static type people, like I would say, Smalltalk leverages confidence, Haskell leverages certainty, and you're not going to eliminate. I wouldn't expect your system to eliminate all type errors to the point where you're certain there would never be one, but it gives you that confidence to move it forward.
Yeah, and then you have also the balance between where the errors really are. Are the errors really type errors, the most important are really type errors or implementations that are not correct or misinterpretation of the requirements and those kind of things. And
you know, I love the Haskell type system, but half of my bugs are either off by 1 errors or getting the then and else switched around.
That's right. That's right.
My bugs are misunderstanding the problem in the first place.
That's right. And you know, I like to say again that I think Smalltalk is a great system. Well, I think we all know that, but you know, Dan and Adele and Alan did such a great job that we're still using it, and we can still do these amazing things. You know, when I started with this idea, you know, I wanted some guys at the university to write their thesis about it, and I couldn't convince them. And one day I said, oh, we have to do it. I have to do it. It took me, I don't know, maybe 30 minutes to make the changes in the VM. It took me like an hour to make the VM compile and those things. But then to make the changes in the VM and try it, it took me like, I don't know, 30 minutes or less. And I said, wow, you know, it was that simple. It was only 30 minutes that I had to spend on this, and I had the types of the variables already in place, of the instance variables. So when I saw that, I said, okay, let's go for it. And again, it was not more than 3 months of work or 2 months of work. So, you know, that's amazing.
But the difficult bit, Hernan, is getting that clear understanding of the problem you're trying to solve in the first place. So when you sat down and spent that 30 minutes writing that code, you had a very clear idea of what you wanted to do.
Yeah, of course. Yeah, I agree.
Independent of all the cool type stuff, I thought that your VM modifications would make like just an excellent beginning tutorial on how to make basic VM modifications. And you know, and that's cool. Just I can I can kind of see what you're doing just in those VM methods that you flipped up there, which was very nice. And the other thing I loved, even though it seems so trivial and obvious, but once I saw it, it's like, wow, that's brilliant. You know, you're in Smalltalk and you got a pop-up menu with a giant list of selectors, and it's which one do I want? And just seeing the source code flip up to the right of it. I mean, it's not even the source code, just seeing the comments there.
Yeah, that's
like,
right.
Wow, that was great.
Thanks.
Hernan, I'm going to head off. So thank you very much indeed for presenting this, and thanks for having all the ideas and actually realizing them as well. But also thanks to Tim and Giovanni for organizing the session as always. So
okay, thank you. Thank you for your comments.
I think we have to say to Giovanni, he's been doing a lot of the legwork on this to find speakers. But I mean, I guess thanks to the community for everyone to come up with the ideas and keep, throwing more out. It is amazing. I think I echo that thought that, the beauty of Smalltalk is just, it's amazing what you can achieve, and even things that, I've thought, oh man, I would never be able to do something like that. And before you know it, you're sucked in, and you're making those changes. The other day, I was looking at the Squeak.js VM, and it was like, oh, I'd never be able to write a plugin, but I wanted to do something. And so I had a little look around. It's just like, oh, this is pretty easy. So, you wrote something, and next thing you know, you're able to do more things that you didn't think were possible. It is fantastic. And the simplicity of everything. I think that is the forgotten thing in our world of technology. It's just everything seems to get more and more complicated. And I just love the simplicity of the Smalltalk environment. Every time you look, you're like, that's got to be too complicated. I'll never know. And then you look and it's like, oh, it's so simple. It's really easy. And I think, that joy of simplicity is fantastic. I hope we can preserve it and share to the world, keep sharing to the world. Just, we need to bang on about this because, every time I look at things that people are adding, and it's just like, how do people write software these days? It's becoming insane.
Yeah, I agree. And I would like to add that it's not only simplicity, but also consistency. And, the other day I was telling Dan that I don't know why people don't realize yet that how blocks in Smalltalk and closures are created, code blocks and closures are created with the same syntax, just square bracket. And if you go to other language, you don't have that. If you go to Java, code blocks are, the C kind of creating code blocks, and lambdas that are not even closures. Lambdas have a different syntax. And if you go to C#, the same thing. If you go to C++, the same thing. But in Smalltalk, they realize, code blocks and closures are the same thing. Are just a collaboration, a set of collaborations. So we use the same syntax, and that's consistency and simplicity also. And those are the things that, for example, at least for me, in the last few months, get me thinking about how they did it. But anyway, we have Dan here. He could say that, but I don't know if he wants to.
Well, it's great just to see the energy in the community, keep continuing to do really creative things. It's great what you've done, Hernan.
Thank you, Dan.
I do have a question related to that. You mentioned that when you change a method, you reset everything. Do you have to explicitly reset that, or is that just a side effect of how the system works, that it creates a new object, so the array is attached to the old object? Do you have to do anything?
It's how the system works, because when you compile a new method, it creates a new method. So I attach to that new method a new additional method state. So it's as simple as that. Yeah.
Right.
It's not the case with classes. I think that with classes, I had to reset the instance variable row types explicitly.
Yeah, because very early.
It's copying when it creates the new class. It's copying. I think, it's copying.
The identity of the class is maintained as you modify the class definition.
That's right.
You do a new method, it's just a brand new method, and the old one just disappears once you get a ref to it.
Yeah, some old Smalltalks, like for example, the original Smalltalk V, you weren't allowed to change a class that had any instances. So first you had to have all the instances become nil, and then you could change it. And then we added all the mechanisms to reshape the instances when you change. So that probably is getting in the way.
Yeah, that's right. Yeah, but keeping the and resetting that cache of types is something that more work has to be done on that. Yeah.
Any further questions on this one? If there aren't, I'll stop the recording. People are welcome to hang out and chat about any other topics. I think Giovanni likes me to sort of end the recording just so that it makes it easy for him to chop it up and upload it onto Vimeo. And I think sometimes he has to split it to make it available, but he is working through. I think he did say that, Craig, I think yours is still waiting to be uploaded because he's had a few bandwidth problems, but we will get them all up. They are fun to watch. There's been a lot of good talks, and this one was again an amazing one. So thank you, Hernan.
No, you're welcome. Thanks to you again for giving me the chance to show it.
Yeah,
So I'll stop the recording now, and then if anyone wants to hang out and just chat about random stuff, sometimes the after talks are quite interesting as well. Lots of topics are covered, but I'll stop things now.
Thank you, Hernan. Great talk.
Thanks.